Hello, and welcome back for the midterm review. This is the section on chapter 6. And there are two questions here at the beginning that I'm asking you to do by hand, just to show me that you understand either substitution or elimination. And I'm going to choose substitution on this first one by taking row 1 and solving for y. So I get that. So now that I know what y is, I can substitute 3x minus 8 into the second equation for y. And then I'm going to distribute the 3. And I'll get 2x plus 9x minus 24 equals 6. And then 11x, adding the 24 to both sides, I get 11x equals 30, and dividing by 11 to solve, I get x equals 30 over 11. And then substituting that back into the original equation for y, I get 90 over 11 minus 8 equals, and that's the same as 88 over 11. So that becomes 2 over 11. So x equals 30 over 11 and y equals 2 over 11. Okay, then it says use either substitution or elimination on the next one. The next one I'm going to use elimination by addition because they're lined up and I think it should be fairly easy. So I'm going to choose to eliminate y because they're already opposite signs of each other. So I'm going to do 3 times row 1 to get this to be 15, a negative 15y. So that becomes 9x minus 15y equals 48. And then that means I have to take 5 times row 2 so that I get 10x and plus 15y equals a negative 10. That way, when I add the y terms together, they add to 0. And I get 19x equals 38. And dividing by 19, I get x equals 2. And then I can put x equals 2 back into either equation. So into row 1, I can say 3 times 2 minus 5y equals 16. And solve for y. So by subtracting 6 from both sides, I get a negative 5y equals 10. And dividing by 5, I get y equals a negative 2. So my solution is 2, negative 2. And then number 20, bigger problem. It says an office supply manufacturer makes 2 kinds of paper clips, standard and extra large. To make 1,000 standard paper clips requires a quarter hour on cutting machine and a half hour on a machine that shapes the clips. Making 1,000 extra large paper clips requires a third hour on each machine. The manager of paperclip production has 4 hours per day available on the cutting machine and 6 hours per day on the shaping machine. How many of each kind of clip can he make? So because we want to know how many of each kind of clip, those are going to be my variables x and y. So x is going to be my standard and y is going to be my extra large. And then I'm going to write out my equations. So I've got a constriction, a restriction on cutting, and I've got a restriction on shaping. So the cutting for the standard says it takes 1/4 of an hour of the standard. And then the extra large takes 1/3 of an hour on that. And it says that they limit the cutting to 4 hours a day. And then for the shaping, it only takes a half hour for the standard, but it still takes 1/3 of an hour on the shape on the extra large. And they're limited to 6 hours per day. So you can use matrices for this by putting in this in your matrix. Here. So I'm going to show you what I did here. So I put that in, and then here is my matrix. So I'm going to put me up here. So I put that in, it's my matrix A, and then you're going to do the RRF down here where my mouse is. My mouse is down here, RRF. And then you do that of A, the reduced row echelon, and it gives you 8 and 6. So the solution is, I'm going to write that here. So 8,000 of the standard clips and 6,000 of the extra large clips. Now the next 3 systems, I'm using matrices for each of these. So I'm going to show you. These are all lined up. So you can see these here. I put that in this is matrix B. So when we put it in matrix B and we run our reduced row echelon, you can see my final answer comes out to be 0, 0, 0, 1. So that's an untrue statement. 0 cannot equal 1. So that means that there's no solution on number 21. And then number 22, that matrix is going to be my matrix C. And that is going to be 1, 0, 1, negative 3, and then 0, 1, negative 1, 6, and then 2, 0, 3, 5. And when I run that reduced row echelon, that comes out to be a negative 14, 17, and 11. That's matrix C on my screen. Let me know if you need help with any of these. And then my last one is going to be matrix D. And so that one is 3, 1, negative 1, 3, and 1, 0, 2, and 6, and then a negative 3, and negative 1, 2, and 9. And when I run that reduced row echelon, I came up with x is equal to a negative 18, y is equal to 69, and z is equal to 12. That's what I have on my paper there. And that's for number 23. So catch me back if you have any questions. And you can check out the videos for chapter 7, chapter 5, or chapter 2, one of the other chapters.